Hi, my name is John Griffith. I'm the developer of the Tipping Point data puzzle, and in this video, I'm going to describe the identifying important science ideas practice in the context of the tipping point. So the goal of this practice is to identify important science ideas that are introduced in an interactive reading we call the puzzle plot. And so in this practice, you're going to help students connect science ideas from the reading back to the opening scenario. Students are going to be tasked with summarizing key ideas by creating an annotated sketch, which will serve as their initial model. And then students are going to make predictions about the investigative questions scientists are seeking to answer. We've had teachers facilitate this part in a couple of different ways. One, by reading the text as a whole class, pausing to play any embedded videos or discuss any prompts that are included in the text. We've also had classrooms where students have read the text individually and utilize close reading strategies that are already established in the classroom to help make sense of the text. So up to you as the facilitator to figure out how best to meet the needs of your students. This practice, here's a slide directly from the slide deck. So in this practice, you're gonna say, let's learn more about the work of Megan, Bill, and Dan, these ecologists, by reading this puzzle plot text. And when students are reading the text, you're gonna have them circle the investigative question the scientists are seeking to answer and identify and maybe underline any similarities between the reading and the opening scenario that you can discuss after reading the text. And so reading the text, pausing to watch any videos. There are 3 videos in this particular data puzzle. And then once students have had an opportunity to read the text, watch these videos, we'll challenge them to make connections between the text and their experiences that were drawn out in the opening scenario. Asking students to think about how measuring Moss-Campian vital signs might be helpful for these scientists in terms of figuring out the overall health of the plant. Thinking about how vital signs are similar between plant and humans. So again, we're trying to draw out these ideas that if we can measure vital signs, whether it's a human or plant over long time periods, we might be able to measure, observe changes, and make predictions about the overall health of the plant or the human, depending on the subject being measured. After students have read the text, had an opportunity to make connections between the text and the opening scenario, we go back to the student worksheet where it's time for students to summarize these important science ideas by first drawing and describing how Moss-Campian plants have adapted to their unique tundra environment. And again, this will serve as their kind of initial model. Students will record the investigation that they circled in the text and then make a prediction about the investigative question. I'm gonna move to the student worksheet right now and show you what that looks like. So here's the student worksheet, here's the puzzle plot text. We've got an image here of the Moss-Campian tundra plants, a location map showing the different field sites where scientists are measuring the vital rates of this plant. You can see here we've got a couple different videos embedded in the text. The videos range anywhere from 2 to 4 minutes. And then a couple of questions. This is the graphic that students will annotate to show the adaptations Moss-Campian plants have. Record that investigative question and then make a prediction here. When students have completed these different tasks, they're ready to move on to part 3, where they'll analyze a data set to test their prediction about the investigative question.